This problem is problem number 5. It's coming from trig review number 1. So this is what they want us to do. For some right triangle, sine of A is equal to 0.6. And the question is what could the side lengths be? Explain. Okay, so 0.6. So let's see if we can express 0.6 as a fraction. So if I think of 0.6, I have 0.6 equal to, let's see, that's just 60% or 60 cents. So 6 out of 10. So it's represented as a fraction. All right. Let's see. So for some right triangle, so we're going to draw a right triangle, a very basic right triangle. Excuse my drawing. So right triangle, and I'm going to color in this angle right here. We're going to call this angle A. This is going to be our reference angle, angle A. So now with respect to that angle, I'm going to label the sides. So this side right here is going to be the longest. It's also known as a hypotenuse, denoted by H. And how do I know that? Well, it's across from this 90-degree angle. Remember that the largest angle is across from the largest side. So now the side that's here next to the angle A is the adjacent. So I'm going to label that with the letter A. A for adjacent. And now the side that's opposite of this angle is this side over here. I'm going to label that as O for opposite. Okay, what could the side lengths be? Okay, so now if I rewrite sine of A, so sine of A has a fraction instead of a decimal, we have that sine of A is equal to 6 upstairs and 10 downstairs. So if we remember what this means, our basic trig definition for sine is, so sine of A is also equal to O on top and H on the bottom. Okay, so O is here and H is here. But 6 is on top and then 10 is on the bottom. Therefore, it must be that O has to be 6, H has to be 10. Right now, we're wondering what could the other side lengths be? So this is A here. So we can solve this using the Pythagorean theorem, right? We have two sides and we need to look for the other side. So we can go that route, or we can also notice that this triangle looks very familiar to this other triangle right here. If we remember, previously we've seen this triangle before. This triangle had sides 5 for the hypotenuse, 3 on one leg, and 4 on the other. Okay, now notice these two triangles are similar. Okay, so what do I mean by similar? So these angles, these red angles, are exactly the same, and this other one that we don't know matches up with this other top one. I'm going to shade that in for you. Use blue right here, and this angle blue right here. And both of these right triangles have a 90-degree angle. Now, this side that contains the 90-degree angle and blue angle is 3, while on this side is 6. This bottom is, so the bottom side that contains the red angle and this 90-degree angle is 4. And on this side is also, well, we don't know, right? It's A, the adjacent side. On this side, this 5 is between, or this side length contains this red angle and this blue angle. While on this one, the H is 10. Now, if we scale it, This 3 to 6, 5 to 10. So what number would give us from 3 to 6 and 5 to 10? What's 2, right? So we multiply all these sides by 2. So multiply all sides by 2. Then we obtain the sides. Then we obtain 6 for this side. For this one, we obtain 8. And for this other one, we obtain 10. So this is also known as a Pythagorean triple or triplet. So this A is going to be 8. Okay. So our sides for some right angle, where sine is A, okay, we don't know the degrees, but what we do know is we know the two sides. This last side has to be 8. Okay, so that's just one way of thinking about this problem.